Hello, today I will be presenting the paper TernaryNeRF, Reducing the Precision of Positional Encodings. Neural readiness fields, or NeRF, has emerged as a revolutionary technique that synthesizes a novel view image by learning implicit representation of 3D scenes. Later, instant NeRF was proposed, which introduced multi-resolutional positional encoding. They used hash tables to accommodate the numerous feature vectors, which greatly reduced the model size. However, the hash tables are still not at a portable level, so we explored the possibility of quantization to further compress the model. Before establishing a strategy of quantization, it is necessary to understand what the positional encodings learn to represent an object or scene. Here's a 2D image which we trained the model on, and the training results on positional encoding at coarse and fine levels. We can observe that the cells corresponding to each object exhibit large magnitudes, while the cells of background tend to have small ones. On top of that, in the final levels, the feature vector elements on the boundary and the interior of the objects often have opposite signs, possibly to represent a clear boundary. If the ternary pattern is consistently observed, then why not constrain them into 3 states? Therefore, we introduce ternary quantization, which stores each feature element in a 2D storage, naming it TernaryNeRF. We take 2-step quantization to train TernaryNeRF. First, we train the model on 16-bit settings and then fine-tune it under 2 bits. In the fine-tuning phase, we do not update the trainable occupancy grid, which is built in the original instant NeRF. Despite the aggressive quantization, we observed only slight degradation in PSNR metric, not even larger than 1 decibel. The renderings also show that TernaryNeRF well preserves the representation of the objects. Our work offers nearly 8 times reduction in model size at a negligible loss of image quality, which sheds light on the feasibility of more efficient training and inference in future NeRF models. Thank you for watching.